Hello guys, welcome back to my channel. Today we're going to be looking at the January 2018 CXC Mathematics Paper 2 past paper. Alright, let's get right into it. You have 2 or 40 minutes to complete the CXC Mathematics paper. Now let's go down. It says answer all questions in this section. The first question says using a calculator, otherwise calculate 5.5 divided by 3 and 2/3 plus 1 1/4, giving your answer as a fraction in its lowest terms. Now, of course, since it says using a calculator otherwise, we're going to start by using the calculator and see what happens. Now, to get the mixed fraction on my calculator, I'm going to have to go here where I press shift and I press this button here. Here it comes up. So I'm going to put in 5. I go to the right. I'm going to put in a half. Good. Go to the right. Divided by 3 and 2/3. So once again, shift, press fraction bar. We put in the 3. We go to the right. 2. Come down, third. And of course, add it to 1 1/4. So you're going to do the same thing. Shift, fraction bar, 1 and 4/5. And that's it, equal. That's 33/10. And of course, we can go back and put it back as a mixed fraction since the question started out as a mixed fraction anyways. All right. Okay, let's get right into it and see what happens. Now, what if you decided to go otherwise? All right, that's the question we're asking. What if you decided to go otherwise? All right, let's see. Now, by looking at this, most of us would have known the operation BIDMAS. BIDMAS. We have to follow the order of operations, which means that whenever I see division, I have to divide before I can possibly add. So what I'm going to do right away is to turn these fractions into improper fractions, right? So we say 2 times 5 is 10, plus 1 is 11. So you have 11 halves divided by 3 is 9, plus 2, 11, divided by 11 thirds, or 11/3, plus 5 times 1 is 5, plus 4, 9. 9/5. Good. Now, whenever we divide fractions, we keep the first fraction, which is 11 halves, and we multiply by the reciprocal of the second fraction. Reciprocal, which means we simply flip it. So it's going to be 3/11 added to 9/5. All right, let's do some cancellation now. 11 into 11 goes 1. 11 into 11 goes 1. There's nothing else to be reduced here, so you know we multiply across. 1 times 3 is 3, so that's 3/2 times 1 is 2. So you can say 3 halves plus 9/5. All right, let's break that down. Now, to add fractions, we're going to have to give them the same LCM, common denominator. All right, the lowest common denominator. So we want the lowest number that 2 and 5 can go into. Now, if you're having a problem finding this lowest number, all you simply have to do is multiply the 2 by the 5, which will give you 10. Not every time that will be your LCM, but you can still come back and break it down and get the answer. But it's always good to know what the lowest common multiple is, or the lowest common denominator. Now we say 2 into 10 goes 5, and we multiply the numerator by 5. And 5 into 10 goes 2, and we multiply the numerator by 2. Now 5 times 3 is going to give me 15. And of course you have 9 times 2, which is 18. This turns out to be 33/10. Or I can put it back now as a mixed fraction, which is going to give me 10 goes into 33 3 times. All right, 10 into 30 is 3. But you have a remainder of 3, which goes back over your divisor, or your denominator, which is 10. So it's 3 and 3/10. And that can't go any further, of course. All right, so that's question 1A, part 1, and it's complete. 1A, part 2. Here's the next reason for you to use your calculator. All right, it does this question nicely for you. So on clearing that, I have 165 multiplied by 0.38 squared. You have a square in your calculator. Simply press the equal sign. That's 23.826. 23.826. Right. They want the exact value. So you're going to put that there. 23.826 as an exact value. That's what they ask you for, right? Now with that said, we can take our time and we can scroll down. It says, what is your answer in part A2 to 2 decimal places? Let's go back up. 2 decimal places means 2 places after the point. Now here's a point, and you want 2 places after. That's 1, 2. Now when you get to the second decimal place, you're going to have to look to the number to the right. And the rule is that if that number is 5 or above, you round the second place 1 spot up. So it's going to be 23.83. Perfect. So I'm going to go back down and put that in. So I'm going to scroll down right here to 2 decimal places. It's going to be 23.83. 3 significant figures. All right. Now, bear in mind, as we go back up to look at it, significant figures include the first set of non-zero digits, right? So looking at these numbers, all of these numbers will be significant because they're not zero. Zero is significant depending on where it falls. But we don't have a zero here, so we don't have much to worry about. The first significant figure is 2, the second significant figure is 3, and the third significant figure would be 8. Once again, we look at the number to the right of 8. Is it 5 or above? No, so we're not going to be rounding up. It's less than 5, it's 2, so we leave it as it is. So it's 23.8. So let's go back down now and plug that in. So we're going to scroll down, and to 3 significant figures, it would simply be 23.8. We done? To the nearest whole number. All right. Now, when you talk about whole numbers, you know we're looking at the ones position. All right, because anything after that is a decimal. We don't want any decimal, we want a whole number. The whole number start from 0, so 0, 1, 2, going all the way up. So to the nearest whole number, it means we're looking at the ones position, right? Now, in a ones position, you have 3, and to the right of 3, you have 8. 8 is 5 or more, so 3 goes up 1 place, which is going to turn this number into 24 to the nearest whole number. So let me go back down and put that in. So this is going to become the nearest whole number. This number right here would simply be 24. That's it. Now let's take this down. We are now at question C. All right. Let's see what happens here. All right, so I'm going to stop sharing so you can see the question clearly. All right, let me just put this all the way over to the right here so you can actually clearly see my question. All right, it says, Mr. Adams invested $5,000 at a credit union and received $5,810, inclusive of simple interest, after 3 years. Determine part A, the simple interest paid. All right. Now, of course, the money he received would include the simple interest because he said he received 5,810 inclusive of simple interest. Determine the simple interest. All right, so we only need to subtract, so we can say the simple interest here is simply going to be 5,810. Let me make sure this is the dollar sign here. 810 subtract what you invested, which is called the principal. All right, very important terms to know. All right, so this becomes $810 as the interest. Don't forget the dollar sign. All right, without the dollar sign, it's not money. All right, take this down some more. The annual interest rate paid by the credit union. All right, let's start with what we know. You want the interest rate. Let's start with the formula. Simple interest is simply equal to the principal times the rate times the time all over 100. The simple interest we know is 810. The principal we know is 5,000. The rate we don't know, we're going to put it back. And I'm almost 100% sure that they said that the time was 3 years. Let's go back up and look. 3 years. So times 3. Let me put that in. Times 3 all over 100. Now let's lose up some little techniques here. Alright, zeros can be cancelled out. Alright, so you get rid of that first. Now next you can say 50 times r times 3. So I'm going to have 810 equal 50 times 3, that's 150, and you put back the r. Alright, now we can divide both sides by 150 over 150, and that is where I would need to bring in my calculator now. So let's put that up. So we're going to say 810, so 810 divided by 150 would be equal to 5.4. All right, good. So my interest rate would be 5.4%. Without a percent, you know it's not interest. Let's go down. The length of time will take Mr. Adams' investment to be doubled at the same rate of interest. All right, good. Now, if it's going to double, remember that he invested 5,000. If it's going to double, he's going to end up with 10,000. Now, how do I look at this? Bear in mind that simple interest is equal to the principal times the rate times the time over 100. If it's going to double, it means that what he's going to put in, the same interest will go on it. So the simple interest will be the same amount of money that he invested. So when you add the simple interest to the amount he invested, now you had double what he had initially put in, which is 5,000. So if he's putting in 5,000 for the money to double, he has to get a simple interest of 5,000 on that. So at the end of the day, when you add the principal and the simple interest, you have 10,000, which is double the initial amount. Good. So we know that in this case, the simple interest is going to be 5,000. The principal was 5,000. They say use the same rate, which is 5.4. And of course, you don't know the time, which is what you want to find. Call it T all over 100. Now the concept remains, work on the zeros. All right, let's break this down. You have 50 times 5.4. Make use of your calculator now. So I'm going to have, I'm turning this on, 50 times 5.4, 270. All right, let's see. Let me make some space here. So I'm getting 270 here. So I'm going to say, all right, 5,000 equal 270t. I will divide both sides by 270. And we all know that time is in years, right? So t would be equal to, once again, our calculator would be needed here. Let me just put there so you can see it. So I'm going to have, let me clear this, 5,000 divided by 270 equal, let's break that down, 18.518. All right, so basically this is going to be taking 18 point something years. All right, so let's go back and put that in now. So that's 18 and a half years. Let me put that there. So it would be 18.5 years or 18 and a half years basically for it to double. All right, let's move into question 2. And it says, given that a asterisk b means the square root of all of a plus 4b, where the positive root is taken, determine the value of 1 asterisk 2. Let's make a comparison here. Now look at the position of a. 1 is in the same position as a. And look at the position of b. 2 is in the same position as b. So it means when I go 1 asterisk 2, I'm going to put 1 in the position of a and 2 in the position of b. So I'm going to have 1 plus 4 times b, and b is 2, which is going to be the square root of 1. 4 times 2 is 8. 8 plus 1 is 9. And that is going to give me 3. All right. So technically speaking, that's exactly what I get. So I just simply use a comparison. Look at what is in the same position as A, and you replace A by it. Look at what is in the same position as B, and you replace B by it. And that's it. All right, whether the operation asterisk is commutative, justify your answer. Now, if it is commutative, then of course you know that A asterisk B will be the same thing as B asterisk A. Just like how 1 asterisk 2 would be equal to 2 asterisk 1. We know that 1 asterisk 2 already is 3. Alright? Now let's go 2 asterisk 1. If you go back up to the expression, It means that when you have two asterisk 1 now, 2 is in the place of A and 1 is in the place of B. So you replace A with 2 and B by 1. So let's see what happens. I'm going to have a square root of 2 plus 4 times 1. 3 equal square root of that 6. 3, well, square root of 6. 3 is definitely not equal to the square root of 6. 3 is equal to the square root of 9. So therefore, we can see that asterisk is not commutative. Alright? So when you turn it around, you don't get the same answer. So it's definitely not commutative. We can all agree on that. Alright, let's go down. B part 2, B part 1. Solve the inequality. Alright, let's get right down to business. We're going to treat it like a regular linear equation. Alright, so you have 3 minus 2x equal, well, is greater than 5. What I'm going to simply do is to bring over the 3, and since it's positive, it goes over as a negative. So you're going to have minus 2x is greater than 5 minus 3. Minus 2x is greater than 2. Now, notice what happens whenever you divide. Notice this side is greater, but I'm going to divide by a negative, which means that it's going to change sign, and this side is going to become less. So I'm going to have negative 2x over negative 2. Because we divide by a negative, the sign becomes less than 2 over negative 2. So x is less than negative 1. So every time you divide or multiply by a negative, alright, the side that was greater will become less, and so you turn around the sign. Alright, you treat it like a regular equation, apart from the fact the sign changes when you multiply or divide by a negative. Represent your answer on the number line. So you want x is less than negative 1. Alright, no problem. I'm going to have to find negative 1 first of all. And I'm going to put a open circle. Alright, you only shade the circle when you have the equal part attached to it. So because it's less than, shade. And of course, less than is to the left, greater than is to the right. So you're going to go down. That's it. X is less than negative 1. And you get an easy one mark there. Now, please use a ruler to get the line straight. Alright? Let's go down to question C. 2 adult tickets and 3 children tickets cost $43. Statement 2. 1 adult ticket and 1 ticket for a child costs $18.50. The question is, let X represent the cost of an adult ticket and let Y represent the cost for a child ticket. Write 2 equations. So, okay, this part should be straightforward. Alright, so X is the cost of an adult ticket. So Y is the cost of a child ticket. You have 2 adult tickets, so you're going to have 2X. And 3 children ticket, so 3Y, because remember Y is the cost of 1 child ticket, is equal to 43. 1 adult ticket, so just X. I don't have to put 1X because X by itself means 1X. And 1 child ticket, so X plus Y, we don't have to write 1Y, is simply equal to $18.50. Alright, $43. Alright, good. So these are 2 equations that would technically speak represent the situation that is given below. Alright. Now, of course, part B, once I ask you to write something like this, it's naturally going to ask you to solve it. So solve the equation to determine the cost of an adult ticket. Alright. What I'm going to do, I'm going to go ahead and write back the equations, and I'm going to determine what method we're going to be using. So I have 2x plus 3y equal 43. I don't need a 0.00. And I also have x plus y equal 18.5. Also don't need a 50. Now, in this case, I could use substitution, I could use elimination, whichever way I want to do it. Alright, so probably for me to use elimination, I could make the x's the same, so I could go ahead and multiply equation 2 by 2, 1 by 1, right? So you have 2x plus 3y equal 43, unchanged. Alright, this will be 2x plus 2y. Of course, this is going to be equal to 2 times 18. 2 times 18 is 36. 2 times a half is 1. So you're going to have 37. We'll go ahead and subtract. 2x minus 2x, that's gone. And that was the aim, to eliminate the x. And you have 3y minus 2y is just y. Of course, 43 minus 37 is simply going to give me 6. Now, once you have the value for y, you simply put it in the easiest equation of your choice. I could put it in the second equation here. X plus y equal 18.5. Alright, so it means that x plus 6 equal 18.5. X is equal to, the 6 is positive, so it comes over as a negative. 18.5 minus 6. X is equal to 12.5. Now remember, this is money. Alright, so X will be equal to $12.50 for one adult ticket, and Y would be equal to $6, and that's for a child ticket. So one adult ticket costs $12.50, and a child ticket costs $6 flat. Alright, elimination is never too bad to use when you have two linear equations. Pretty interesting technique there. Now let's go down to question 3. Says the universal set U, and we have the set B, D, E, F, G, H, I, K, S, T, V, W. So we have a Venn diagram. We have three different sets. We have M, P, and R, which are subsets. State the number of elements in P union R. P union R means that you join P to R. What they want is the number of elements in the two sets combined, P and R. So you're looking at P and R. Alright, so here's P up here, and here's R. You want to combine all the number of members. In other words, they want to tell you how much you see. So let's look in all of P. Remember, the circle is all of P, so you have 1, 2, 3, 4, 5. Well, this is all of R actually. And then of course you're looking at P, right? So these are all the elements in P combined with R. So in all, N means the number of. In all, you have 1, 2, 3, 4, 5, 6, 7, 8. So this is simply equal to 8. Now notice they're not asking you to list the actual members. They're asking you how many elements do you see in P or R. Alright, now list the members of M intersect P. Intersect means what is common or the overlap. So if I'm looking at M intersect P, I'm looking for where M and P overlap. So this is M, this is P. We can see that they overlap right here at B and D. Remember now, only M and P we're looking at. So this will just be the set B with D combined. That's it. Alright, let's take this down some more. M union R complement. So you're going to join M with what is not in R. Okay. Alright, so let's see. In M, and let me use a different color. Let me use green. In M, you can find these. All these are in M. And you're going to union it with what is not in R. Union R complement. R complement means what is not in R. And the question is, what do I not have in R? Now remember watching the green lines, guys. So green, what is not in R? This is not in R. This is not in R. This is not in R. And that is not in R. So I'm going to be union, because it's union, it means we're joining everything together that is common. Well, not that is common. Everything together that we have in green. Alright? So we're combining everything. Guys, remember, we're looking at the union. Unite, join. So this will be the set with everything basically. Apart from G, E, and F. So I'm gonna have, let me see if I can get this in order now. I'm gonna have B, D, so I'm gonna have B, D, keeping it in alphabetical order, B, D, I, K, so B, D, I, K, S, T, V, W, S, T, V, W. And that would be it. Now the next one is a construction. It says use a ruler and a pencil and a pair of compasses. Construct triangle PQR with PQ equal 8 centimeter, angle PQR equal 120 degrees, and QR is equal to 5 centimeter. So we're going to have to start with a baseline. So let me just quickly sketch up a triangle so we can sketch it from that. Alright, so let me go with PQ. Let us imagine that this is PQ and PQ is 8 centimeter. Alright, PQR, so PQR is 120 degrees. So I'm going to put R here. And here is 120 degrees. And QR is 5 centimeter. Alright, so that's basically my triangle there. We're going to get right into it. Alright guys, we already have our basic idea of how we want the layout to be, so I just need to get into construction mode now. So let me go. I'm just going to take my ruler here and I'm going to draw what I call the baseline. According to this, the baseline, I'm going to use it as PQ and I'm going to make it 8 centimeters long. Alright, now I'm going to actually draw a construction line. I'm using yellow now. Remember, your construction line should be pale. I'm going to use yellow for my construction line. Now notice what I'm doing. I'm going to pass at 8 centimeter mark, and for my solid line, which needs to be exactly 8, I'm going to make it black and bold. I'm going to make it exactly 8 centimeters. Alright, so remember, in your words, the construction lines should be pale, so I'm making it yellow for you to distinguish it. You make it pale with your pencil, and then I'm going to make my actual lines bold. So let me move this and let you see what's happening. So my black line is 8 centimeters, right? So let me put on, this is P. This is Q right here. I need the additional space for me to do my construction. Now, since I want this to be 120, what I can simply do is construct a 60 on the opposite sides, because angle at a point on a straight line measures 180 degrees. So let me go for my compass. So I'm going to bring it here. I'm going to put it right here at this mark right here. Make sure that it goes on, because being off by even a small amount could cause a problem, right? So my compass is right there. Now I'm going to swing an arc. Alright, let's see what happens here. Right, here we go. Let me make this a bit smaller. Condense it. I'm going to move it to this point right here. And make sure it's exactly at the point. Alright, good. Now I'm going to swing an arc. I'm down here going up. Alright, now of course, probably I could make, since the arc is a part of my construction line, I could probably make the arc pale. So let me take that back out. I'm going to erase the arc that I have here, because I want to make this arc pale. Good. So I'm going to use the yellow line, because it's a part of my construction line. Alright, let's get into it. Now I want this arc to cut the yellow line, so I'm even going to condense this down some more to make sure it cuts that line. Here we go. So that is my arc there. Now I'm going to take up the compass. I'm going to take it up. I'm going to put the point right where the arc cuts the line. Alright, remember again, this is a part of my construction line. And I'm going to swing an X arc cutting this. Good. So let me move this. I don't need this now. So what I'm going to do is that I'm going to draw a straight line through this point, And of course on this side would be 60 degrees, so the opposite side would of course naturally be 120. Now because I know that it should be 5 centimeters, I can use a solid line. So let me rotate this here. Here we go. Right, let me try to line this up as best as possible. So I need to take this around a bit more. Right through there. It needs to be exactly. Take it down some more. Rotate this. So I need to ensure that these points are lined up perfectly so I don't make any mistakes. Now I'm going for 5 centimeters. So let me just bring the 0 point up here. So that is 0. Alright. Now I'm going to be using a solid line because I'm sure of what I want. I want this solid line to go to 5. Right, so let me use a black line, exactly 5 centimeters. Alright, Control Z. This is going off a bit. Let me go again. Exactly 5. Right, that's it. So let's move this now and see what happens. Alright, a little off, but up here now I could simply put on my, right, let me see. So that's PQR. I could call this R. Of course, this is 5 centimeters. Let me not put on that. This is 8 centimeters. Let me put on that as well. And then this would be 120 degrees. Don't forget to put that in. Then I need to complete it to get my triangle. So let me bring this out here now. So I'm going to join P to R. Right, not so bad there. Right, let me see. That's about it. All right, so let me go there and drop this in. All right, come on. The line that I want here. All right, now a very logical question that could come up is that they could ask you for the length of PQ. This is not so perfect because, of course, we're using the virtual screen. All right, so that's PQ. They could ask you what is the length of that. And at this point, I believe it's like approximately 11.5 centimeters. All right, so let's go back and see what happens in this case. All right, now the rest of the question, although it's not showing here, had asked us to measure PQ, which we had done initially because we assumed that that's something they might ask. I found out that this was 11.5 centimeters, so that's okay. They're also asking us to complete this to form what is called a parallelogram, PQRS. Now, if we know parallelograms, we know that opposite sides are equal and opposite sides are parallel. So what it means is that this 5 centimeter side over here, there's going to be a side over here at P, which is also parallel to this. Good. Now with that knowledge, this is going to be pretty straightforward. Because for the opposite sides to be parallel, the opposite angles must add up to 180. So if this is 120 degrees, the angle that I put over here must be 60 degrees. Alright, so I need to construct a 60 on this side. Alright, let's go back to our construction line. We're simply going to put, let me move this now. we're simply going to put the compass point here at this point. Alright, good. We're going to swing the construction line right here, as you can see. Let me extend this because I'm not seeing it how I want it. Alright, so let me insert this again. Reduce the size. I'm going to pull it down here. I'm going to put the compass point right here. And I'm going to swing an arc. That's it. I'm going to take, without adjusting the compass, I'm going to put it right here. And I'm going to swing the next arc, cutting the first arc. Very good. So I'm going to have to bring it back to the first point so I can ensure that the first arc cuts it. Right. So now all I need to do is to draw a line right through the center there and simply make sure that it's 5 centimeters as opposite sides are equal. So let me just quickly perfect this. Let me get this down to this point right here. And let me turn this part up here. So turn. Come on, turn. Alright, good. Now let's set this up in such a way. Alright, probably need to turn it back a little bit. Alright, but I need this to be exactly 5, right? So let me put the 0 mark there. So I can use a black mark because I'm sure that this is now my construction line. Not my construction line, but the line I actually want, right? From down here, should be 5 centimeter going up. All the way up to 5. So I don't miss. And that's it. Good. Alright, so that's 5 centimeters. Alright, so now all I need to do is connect those 2 points. Let me get back my ruler straight. Let me get it back straight. I'm going to put it at the top here. Sure that this is straight. I'm going to connect these 2 points. So bring it down a little. Bring it up. That's me. And I'm going to connect these 2 points right away. Whoa. Alright, so that is me. Now I want you to ignore, let me put on the S, ignore this little line at the top here. Let me rub this out. They shouldn't be there. Alright, let me take that out. And there you have it. I have my parallelogram PQRS. So you have to know the features. Opposite sides are equal and parallel. So if I were to measure this side over here, they should actually be 60 degrees. And you can always check it to make sure. Up here would be 120, and over here definitely would be another 60 degrees. And that's how we construct our parallelogram from our triangle.